Good morning, everybody. This is Ms. Volcano, and today I want to talk to you about your roller coaster project. I want to go through it step by step and let you guys know how it's laid out and what the expectations are, okay? So as you can see right here on the screen, this will be your handout or your assignment that you're going to work out of. And to kind of sum it up, in this project, you are basically going to be given the opportunity to demonstrate your understanding of the law of conservation of energy. This is a summative project. Instead of a test, this is your project, so it's worth 16 points. And let's look into it and let's see what you need to do for this. So basically what you will do is build a roller coaster, so such as the roller coaster that you built for yourself when we did the FET simulation. So you're going to build something similar here. And you're going to explain in this project how energy is converted throughout the process, throughout the roller coaster ride, basically. How is energy converted from one form to another, okay? So at the beginning of your assignment, you will see resources that are helpful. I very highly recommend that you go through all of them in order to support you and help you accomplish this assignment. So the directions specified right here, you're going to start by selecting one form of energy. So your roller coaster, obviously, in order for it to get up to the top of the first hill, it will need to be powered by a source of energy. So as you guys all know, when you ride on a roller coaster, there's usually that chain that brings you up to the very first hill. And then after that, the roller coaster moves on its own. But that chain that first brings you up that first hill, you need to think about what powers that and then what powers the rest of the roller coaster ride. Okay, so you're gonna pick yourself one form of energy. It could be renewable forms such as solar, hydropower, wind, and geothermal or biomass, or it could be a non-renewable form such as coal, petroleum, natural gas, or nuclear. You're gonna pick yourself just one of these forms, and that's the form of energy that you will assume powers your roller coaster up to that top of that first hill. Okay, so once you select your energy source, your first question is to conduct some research about this energy source. And I just want to say that if you have completed your Jamboard that we did in class just this past week, for example, this is this Jamboard that I'm talking about. This is an example of students who completed research on coal. If you completed that, then you basically have pretty much all the answers for this first part, okay? So the first part, which is worth 4 points, so a quarter of the total points, it's asking you to research your energy source, describe how this energy is created in the environment. Is it renewable or non-renewable? What are 3 advantages, 3 disadvantages, and 2 interesting facts? So again, if you have already completed your Jamboard, you should be in very good shape. You should already have pretty much all of this work done. And please feel free to use that work that you completed here. For part 2, also worth 4 points, so another quarter of your total score, you must explain how a power plant uses your energy. So let's say you picked coal, you would explain how a power plant uses coal to produce electricity. Electricity is needed to get your roller coaster up that first hill. So that's what you're explaining here. You're going to identify energy transformations occurring in your power plant. So again, if you have completed your Jamboard, you already have all this information. So going back to this example of people who did coal, they presented their power plant. So here's your power plant. You should all have a diagram of your power plant in this project showing how energy is produced from your energy source into electricity. As for your power plant, you should include and use vocabulary from this list. So gravitational potential energy, chemical energy, and so on. You need to include a diagram, something similar to this, but that is appropriate for your energy source. And you need to show how the energy is converted through the various forms. You need to draw and label all the energy transfers that have taken place, starting with your energy source and ending with electricity. And you need to also identify places where energy is quote unquote wasted to the environment, basically where we are seeing inefficiency. And all of this we have discussed in class. So you're going to end up with a diagram, something like this. What's new for this project is that you actually have to label and draw arrows, and instead of just verbally speaking about the energy, you actually would have to include on your diagram labels and arrows showing what's happening with the energy. So for example, for coal, you would start off with chemical energy. You would end up with electrical energy, and then in the middle you would need to show all of the different forms of energy that are happening in this transformation, as well as you would need to show where inefficiencies are taking place. So for example, you would have something like this on your project where you're showing coal right here. So you have chemical energy, so you'd label that. Whoops, that's not what I meant to do. But you get the idea. You would label chemical energy right here. And then you would label another kind of energy as it's transforming as it goes through this. All right, so let's go back to the project. And then you would need to label places where inefficiencies occur, basically where energy is wasted to the environment. So again, question number 1 and 2, if you have completed your Jamboard, you pretty much have all of these answers already, and this should take you very little time. If you have not completed your Jamboard, then go back to your Jamboard. Remember what we did in class on this, the discussions, the presentations that we had in class. This is the kind of thing that you are expected to do here. For question number 3, also worth 4 points. Now we're going to go to your roller coaster. So now that you have produced electricity in your power plant, okay, so you just produced electricity from coal, if you selected coal, into electricity using your power plant. Well, now you're going to take that electricity and use it to power your roller coaster. So let's say this is your diagram of your roller coaster. You're going to have to make yourself a diagram. Let's say this is your diagram. Well, we all know, if we've been on a roller coaster, that energy is needed to bring your roller coaster up to the top of this very first hill. It's not going to get there by itself. So we need some form of energy, and they use that chain to pick it up, right? They use a chain to bring it up this first hill. Once they use that form of energy and the roller coaster is now at the top of the first hill, now it can just power itself through energy transformations from, and you guys are going to tell me what kind of energy transformations are happening there, okay? So now for the rest of your project, you're basically going to be analyzing your roller coaster ride, okay? So for number 3, it's asking you to draw or insert an image of a roller coaster. And it has these requirements. It only has one electric power chain on the first hill to bring it up. The first hill should be the tallest. It is asking you to label your image with 5 different points. A at the start of the ride, all the way through E at the end of the ride. So something similar to this, but yours would also include point E, okay? So, but that kind of shows, that kind of labeling is what I am looking for. For each data point, so for each label, for each place, A, B, C, D, E, you're going to have to draw 4 energy bars showing the relationship between potential, kinetic, thermal, and total energy in the system. So you're going to use these graphs right here to show what happens to the energy at those points. And if you're a little bit confused on this, I highly suggest going back to this Fed Skate Park activity that is linked right here. And basically what this is asking you to do is to remember these energy graphs that we worked with, and remember how at different points, let's actually put some friction in there. Let's put some thermal energy, and let's see what happens. All right, so you see how we work through how the energy converts from one form to another at different points in the ride. This is what is expected for your project as well. So at different parts of the roller coaster ride, at point A, point B, point C, point D, and point E, which is at the end, you need to draw a graph like this for each one of those points, showing what is happening with the energy. All right, so that is for part 3, and your graphs are right here. So you got one for A, B, C, D, E. So for all of them, draw energy bars showing what is happening with the energy, what forms, how is it being converted. There are certain assumptions you're supposed to make. So you got to assume that the roller coaster starts with 100 joules of potential energy. So at the top of this very first hill right here at A, you got to assume it's got 100 joules right there, okay? And it's not moving yet. Obviously at point A is just, that's where it starts from. And then you got to assume there is friction, and you have to, your graphs have to show that your roller coaster has stopped moving at point E. So at point E, gotta assume that's where people get off the roller coaster. So the roller coaster has stopped moving, and your graph needs to show that. All right, finally, moving on to the last point, last question, question number 4, worth 4 points as well. Now you're gonna write a paragraph explaining how the law of conservation of energy, which we spoke about in class, and if you don't remember, need help with that, it is also linked right here into a video, giving you a little bit of a refresher of that. So number 4, you're going to talk about how the law of conservation of energy applies or is demonstrated through this entire energy transfer project. So explain how the energy is conserved, not created or destroyed, starting with your power plant and all the way throughout the roller coaster ride. And it gives you specific instructions on what you need to do using 3 examples, some examples of vocabulary or terminology that you are supposed to use. Finally, you are given the rubric. So this is the rubric that I will use when grading your project. So as you can see, for every question, right, we had 4 questions. For every question, question 1, 2, 3, and 4, it actually gives you a very detailed breakdown on how you will be graded. So what do you need to do to get 1 point for that question? What do you need to do to get 2 points, 3 points, and 4 points? Okay, so make sure please to complete your project, go through this rubric very carefully, because then you will know exactly what you should expect for a score. Let's see, is there anything else I wanted to tell you? I believe that's it. Again, efficiency, let's talk a little bit about efficiency. So when you are describing places in your power plant or at other places in a roller coaster that you're losing or wasting energy. So these are places where your process is inefficient. If you are having trouble remembering that, there is a video right here for you explaining efficiency that will really help to refresh your memory. And of course, you guys are always welcome to ask me questions on this in class. But I think I covered everything that you need to know in order to complete this project. So good luck, and I look forward to seeing you all in class.